Okay, now we've learned how to loop through a string and check whether there's ATG in the sequence by doing the string manipulations here. But now we get stuck because what we need to do next is say, okay, if there is an ATG, do one thing. If there isn't, just continue. And we haven't learned how to do that yet. So we will learn how this is called a conditional. So one condition to this, other conditions to that. And this is handled in Python by if, elif, and else statements. And we will learn this syntax now. This is a really fundamental part of programming and should be hopefully relatively straightforward. Right, so making decisions in coding, and computer programs are all about making decisions and bifurcations and things like that to control the flow of the program. So in our case, what we want to achieve, very simple initially. Later on, this will get a little bit more complicated. We want to write a function where we loop through a DNA sequence, and then if we find if we find an ATG in the sequence, we want to return the index of the first A in that list, in that sequence. We want to find where is that A, where is the ATG starting, and if there is no ATG, we just return none. All right, so I will want you to understand this flow of events here. So for this, we need to dive a little bit deeper into how if statements work. So let's start very simple. We have a DNA sequence and we ask two questions of the sequence. The first one is length DNA sequence is bigger than 5. Very simple. Is it bigger than 5? Yes. So this would be true. And if it's true, then print the long sequence. There are keywords that you can use for logical operators in Python, so to make this more like natural language. This is very nice. If ATG in DNA sequence, I think everyone understands that. Print has start colon. Okay, so two very simple conditionals here. Let's run this. And yeah, we get the right answers. I think there's something fundamental that we need to talk about here, and this is Boolean. So these conditional statements or these questions that we're asking here are actually returning something. They are giving us a Boolean value, which is either true or false. So if we capture that in a variable and then just print that variable, oops, sorry for my typing. If we print that, what will we get? What will that variable now be bound to? What kind of data? I said before, it's a Boolean, so we will get true. And if we say if it's greater than 20, we will get false. So these type of statements where you ask a question actually return some data. And this is what the if keyword checks. If this is true, then it does that. If it's false, then it does something else. So that's a fundamental part of the if statement that you need to understand. In terms of syntax, it's very similar to a for loop. You start with the if keyword, then you ask your question here. Then you need a semicolon, and then you need an indentation, a tab, or 4 spaces. And then you say what you want to do after. And then when you return back to the normal program, you just come back here to the previous indentation. We can make this more into this is the most simple case where we just do something if it's true, and if not, we just continue the program. We also have bifurcations where we say if there is an ATG, do this. If there is no ATG, say if it's then just say amino acid unknown, for example, and then you just do either this or that and then finish the program, for example. So let's run this just to document this. So yeah, we can say colon ATG codes for M. If we put something else here, so CTG, for example, it will say colon ATG codes, colon ATG codes for unknown. Actually, we should have put this here and say that's the wrong way around. Sorry about that. So yeah, so here we say codon CTG codes for unknown. Um, there's a third keyword, elif, and that's gives you the choice to make various bifurcations. So this happens often where you have several different conditions that you want to check. This can become quite complex, and it's uh, advisable to try and avoid too much complications with these kind of bifurcation and multiplication approaches, but they can come in very handy. So the syntax is always the same. If one thing happens, do that. Then instead of else, you say else if codon is this, then do that. Else if codon is that. Finally, if none of these conditions apply, then print this out. And the program will always scan through, and the moment it finds a true value, it will stop and will not execute the rest. So this needs to be in order. So if you want to check something first, and put that first. So key points to remember here, the syntax always a semicolon after conditions, the comparisons, operators like equal, you have two equal signs, not equal, you have an exclamation mark and an equal sign, you need the indentation, and you can kind of control flow in this way, in a very simple way. We have a lot of practice on this because this is critical. So have a look at the Colab notebooks where we go through this in more detail, and I encourage you to experiment with these things. So the first one is basically single decisions, then we get into binary decisions, then in elif change, so what we just discussed. Then we'll give you more overview of the comparison operators. So equals, or is not, or is bigger equal, smaller equal. So these are very important. They give you different choices to generate logic. You can also chain them and combine them in complicated ways. So that's really sort of the bread and butter of writing good programs, is to design these programs in meaningful ways and control the flow like that. That's what we discuss here, combining different operators. So here we have several with an AND connected, and we could also use OR. There's nested conditions, so it can get very complicated in this way. So reading a program like that is not that simple, but it as I said, try and not overcomplicate things. If you can make it simple, keep it simple, but sometimes we can't avoid it and we get into nesting like that. And then we go through some real world examples. So please study these notebooks carefully. They give you the training and the exercises that you need, and try and change things, experiment with things, and then also answer the questions at the bottom in the end, the practice exercises. Great. So now we kind of know what to do now for our program. We want to find the index of the first ATG. So we run this, and lo and behold, this works very well. It will tell us where the ATG is. So here we can run this very nicely, and we either use the function or we use this simple for loop and if statement here, and it works very well. So you should understand what's going on here now with the string manipulation and the looping through the string, finding these codons in steps of 3, checking whether it's an ATG, and then returning the index. So yeah, let's break this down one more time to make it clear. The function definition, as we discussed before, the definition find ATG and the parameter DNA sequence. Then the for loop to get through the DNA sequence -2, because we want to stop at the -3 position. Afterwards, we won't find the ATG anymore. We have a comparison operator here. We check whether where we are at is an ATG or not, and if we are, we return the index, and then we can do something with that index and start, for example, translating or finding actually the index of the stop codon, and then copying all of that out and translating it. So try that and play around with that. This is already quite a complicated function. You've learned a lot of concepts here, but this is really sort of the key to practice with this. As I said in the first lecture, you need to practice. You can't just listen to this lecture and then you will forget about it. So get your hands at it and play around with these things. And I'll see you in the next lecture.